Statistics 2, S2 that is, November 2021, variant 62. Let's get started right away. The first question. The mass in kilograms of blocks of cheese sold in supermarket is denoted by the random variable m, that's the mass. The mass of a random sample of 40 blocks are summarized, such and such. Find unbiased estimates of population mean and variance. Second part, the price P of a block of cheese of mass M is found using the formula such and such. Find estimates of population mean and variance of P. Now the first part is straightforward. That is, x bar is sigma x over n, but this is not x, this is m. So they keep on changing the variable. M bar is sigma m over n, that is 20.50 divided by 40. Similarly, variance for m, sample variance that is sigma m square over n minus m bar square. So that is 10.7280. This time it's in decimals. 10.7280 divided by 40 minus 20.50 divided by 40 square. So now I'll be using a calculator. Mu bar, that is unbiased estimate of population mean. That is the same thing as sample mean. That would be equal to this value. Unbiased estimate of population variance, that is n over n minus 1 sample variance. I prefer to use this formula. Of course, there is another formula in the formula booklet also. You are most welcome to use it. Naturally, you would end up with the same answer. This is 40, this is 39, and whatever this value is square. So now grabbing a calculator, and the first calculation, that is 20.5 divided by this thing 40. That comes out to be 0.5125. So that's the first thing, 5125. So 0.5125 goes over here. Now what do you observe with my calculation? The thing that you observe is that I set up everything is ready, and then I once and for all use a calculator. I don't keep on juggling between the calculator and my steps. The second thing is that this value is there, it's still in the calculator. I would write it over here, and then after I multiply, this value comes out to be 0.00568590. 0.00568590, and then rounded off 0.00569. This is for 3 significant figures. This one is for later calculations. So later on, if you want to use it, you can use this value. Now what is the next part about? The next part is about linear combination of random variables. P is equals to 11m plus 0.5. Expectation of P is expectation of 11m plus 0.5. That is expectation of 11m plus expectation of 0.5. That is 11 times expectation of m, and this is 0.5. That is 11 multiplied by the expectation of m, that is 0.5125. That is exact. Now a lot of people, they are very weak in the concept that the rule is, let me read it out to you. It says here right away, give non-exact numerical answers correct to 3 significant figures, or 1 decimal place for angles in degrees. This is for non-exact. What does it mean? If it's exact, why worry about accuracy? So don't worry about accuracy if it's exact. Be happy. So now coming back to this answer is this much. So use a calculator and then you get this answer. Similarly, variance of P, what is this all about? Variance of P is actually variance of 11m plus 0.5. That is variance of 11m plus variance of 0.5. Variance of a constant is 0 naturally, and therefore this is 11 square times variance of m, that is 121 multiplied by 0.0056859. 0.0056859, and this is the second answer that you achieve. And naturally, both answers should be rounded off to 3 significant figures because they are not exact. If the first one is exact, you can leave it as it is. So therefore, this is 6.1375. This is 6.1375. If this is exact, that's perfectly fine. Otherwise, 6.1423 is if. And this one boils down to 0.68823 significant figures. And make a habit of writing this also so that the examiner is aware exactly what you are doing. Do not assume anything. Do not assume anything that the examiner knows it all and things like that. Nothing like that. Now, let me, there is no need in this one. I mean, most of the thing that's already there in the examiner report, I'm explaining it right away. But just the key message, let me read this out. All candidates are advised to always read the question carefully. I mean, that is a necessity. All answers must be fully supported with relevant working. Show all working. Candidates should round rather than truncate figures during working. So don't just cut it off. Round it according to the level of accuracy that you have learned in basic maths. Candidates should maintain a 4 SF accuracy throughout their working. Only round the final answer to 3 SF, or if the degree of accuracy is specified in the question. When writing conclusions to hypothesis, the answer must be given in context and there must be a level of uncertainty in the language used. That means sufficient evidence, insufficient evidence, something like that. Don't be like write in black and white. When carrying out significance test comparison between the test value and the critical value must be clearly shown in order to justify the conclusion drawn. So now coming back to this question is done. Let's move to the second question. What is the second question all about? It's about two friends, Andy and Jessica, and they are doing a survey about musical preferences. So it's a survey about musical preferences. They plan to choose a representative sample of 6 students from the 256 students at the college. So this is about sampling. Andy suggests that they go to the music building during the lunch hour and choose 6 students at random from the students who are there. Give a reason why this method is unsatisfactory. Unsatisfactory means it's a biased sample. It's not fair. It's unfair. Number 1, during lunch hour, some people would be at the cafe, so they won't be at the music building. That's one logic. The other piece of logic is not everyone will be at the music building. Yes, they are looking for music representative, but it could be some musician would be playing in a garden or somewhere they would be playing a guitar or something. So it's not necessary that this is true. So that is why these are two reasons that this sample is unsatisfactory. This sample is a biased sample. Now the next part. Now Jessica decides to use another method. She numbers all the students in the college from 1 to 56 and then she uses her calculator to generate the following random numbers. From these numbers she obtains 6 student numbers. The first 3 are such and such. Continues Jessica method to obtain the next 3 numbers. It's very easy. Just write it down, and since this is a 3-digit number, so break it up into 3 digits. So this is like 204 and this is 162. I'm writing the ones in the middle. This is 204. This is 587 and this is 207. I'm writing half in red and half in purple. So 204 393. So let me write it like this: 204 393. 162 007, 204 028, 587 119, 207, and this is 3, 9, and 5. Now, how would you choose? You would choose it like this. You would choose 204 and then 393, 162 007, 204 028, 587 119, 207 395. That's how you choose. Now, this is already chosen, 204, there it is. And then 393 is out because this is out of range. This is not part of the range, this is out of range. Then 162 is chosen, 007 is chosen. Now let me choose more. This is out because it's repeated. Why will I choose two people with the same number? Actually, it's one person, you're choosing it twice. 0 to 8, that makes sense. And what else is there? So the first one that I'm choosing is 0 to 8. The second one is 587, that is again out of range. 119 makes sense, so 119 makes sense. And then 207 makes sense. So these are the three more students that I choose using the method of random numbers. Question number 3. The question says the probability that a certain spinner lands on red on any spin is P. The spinner is spun 140 times. It lands on red 35 times. Find an approximate 96% confidence interval for P. So this is the question about confidence interval population proportion. And what is this question all about? From 3 further experiments, Jack finds a 90% confidence interval, and then a 95% confidence interval, and then a 99% confidence interval. And then it says, find the probability that exactly 2 of these confidence interval contain the true value of P. So that's a nice question. This is like an S1 question. So this is not that much of S2. This is typically S1. First of all, the formula is PS plus minus Z square root PS QS over N. What is PS? PS is proportion of success, that is 135 over 140. What is QS? QS is the proportion of failure, that is 1 minus PS. So 1 minus 35 over 140. The first one comes out to be 0.25, therefore this comes out to be 0.75. What is the value of N? The value of N is 140. What is the value of Z? So Z is based upon 96% in the middle, 2% at the corner, 2% at the corner. So therefore 98%. And as far as I remember, you can double check, that comes out to be 2.054. Just plug in the values. So therefore this is 0.25 plus minus 2.054, a big square root. That is 0.25, that is 0.75, that is 140 at the bottom, at the denominator. Evaluate it, you end up with two answers, 0.175, 0.325, 0.175, 0.325. Since this is population proportion, I can also write in percentage, 17.5%, 32.5%. That is the lower limit, that is the upper limit, but I think just leave it as it is. This is for understanding purposes. Now, this question is about a probability question, a very nice question. And this thing is something about like a basic probability question. That someone is going left and someone is going straight and someone is going right. So there was a car question like this. So basically when it says true value of P, that means the confidence interval percentage. So 90% versus 10%. And let me move it to the corner. And then what's the next one? 95% and then 5%. And then 99% and then 1%. So this contains the true value. This does not. Got the idea? So basically, how do you work? You work like this. That means you take this value. Two of these contain this, this, and this. So the first working is 90 into 95 into 1 divided by 6 zeros. 1, 2, 3, 4, 5, 6. The 6 zeros belong to 100 and 200 into 100. You can write it like this. So this is the blue working. So that's the blue working like this. Now let's move to the second working. That is now the purple one. So now this is 90 and this is 5 and this is 99. So therefore this is 6 zeros at the bottom, and then that is 90 into 5 into 99. Of course you can use decibels also. And last but not the least, that's the orange one. So therefore this is 99 and this is 95 and this is 10. So 99 and 95 and 10, that is the third one. So therefore the working is like this. there are 100 into 100 into 100. I'm writing in a different way. And then this is 10 into 95 into 99. So basically it's either this or this or this. So again, it's a S1 question rather than an S2 question as such. Question number 4. It says a certain kind of firework is supposed to last 30 seconds on average after it is lit. An inspector suspects that the firework actually lasts shorter than this. So therefore, this is lasting shorter than this on average. And suspects, inspector, manager, these are the words that you see. He takes a random sample of 100 fireworks of this kind. Each firework is lit and the time it lasted is noted. Give a reason why it is necessary to take a sample, then testing all the fireworks. I mean, that's a lame question that they have asked. So these fireworks, they burn away. And if all of them burn away, there will be nothing left to sell. That's common sense. Now it says, it is given that the population standard deviation of the times that the firework of this kind lasts is 5 seconds. So the standard deviation is 5 seconds. The mean time lasted by the 100 fireworks in the sample is found to be 29 seconds. Test the inspector's suspicion at the 1% significance level. First thing first, let me grab my normal distribution curve. So that's the first thing. And then it's a normal distribution. Does it say normal? It doesn't say, I just felt like it. So therefore this is 30 seconds. And this is 5 square divided by 100. Before that, write the reasoning. The reason is since n is greater than or equal to 30, that's a large sample. Therefore, CLT applies and the data becomes a normal distribution data. Second thing, H0 mu is 30. H1 mu is less than 30. It's a 1% significance level test. Now let me go over here. This is 1% and this value is 2.326 negative. This is 0. And what else is there? The sample value, the sample mean is 29 seconds. That's the value used for calculation. Now let's calculate Z. Z is X bar minus mu. This is a sampling question. So therefore this is X bar. Don't forget the X bar minus mu, sigma square over n under root. So that is 29 minus 30 divided by sigma square, which is 5 square divided by 100 square root. And then when you would simplify it, this comes out to be negative 2. So this is the Z value of negative 2. Does it lie in the critical region? No, it does not lie in the critical region. It lies on the outside. This is the Z calculated value. What's the conclusion? Do not reject H0. Therefore, we have to accept H0. In the right terminology, we have insufficient evidence to support or endorse the inspector's claim, inspector's suspicion. So we cannot endorse it because we have insufficient evidence. Our state with the reason already stated. Yes, CLT is a must. It is necessary because the distribution was not normally distributed. So it was not normally distributed because of large sample, we made it normal. Question number 5. What is this question all about? In a certain large document, typing errors occur at random and at a constant mean rate of 0.2 per page. So that's the first thing. So let me underline it. Constant rate of 0.2 per page. This is typing error. And find the probability there are fewer than 3 typing errors in 10 randomly chosen pages. So 10 multiplied by 0.2, that is 2, correct? X follows a Poisson distribution of 2. Probability X is less than 3. Probability Z is lesser than or equal to 2. which is 1 minus e raised to power of minus lambda, which is 2. 1 plus lambda square over 2 factorial. Double check your working. If everything is correct, it's just a beautiful coincidence that this is 2 and this is also 2. So I mean, that's just a coincidence. So now this thing is done. Use an approximating distribution to find the probability. There are more than 50 typing errors in 200 randomly chosen pages. So 200 multiplied with 0.2, that simplifies to 40. X follows a Poisson distribution with 40. Since lambda, the mean number of occurrence, is greater than 15, therefore X follows a normal distribution 40, 40. The mean is 40, the variance is 40. Then it says more than 50. Probability X is greater than 50. Draw a number line, mark 50, mark the boundaries 50.5 and 49.5. Mark two number lines. So one number line is emerging like this. The other number line is emerging like this. Which one is the relevant one for us? Since X is greater than 50, does not include 50, therefore 50.5 is the right one. X is greater than 50.5. Continuity correction. Make sure that you explain it to the examiner. So this is normal approximation to Poisson. So probability Z is greater than 50.5 minus 40 divided by root of 40. Let me grab my calculator and subtraction, and this comes out to be 1.660. This is a rule of S1. Probability Z is greater than 1.660. This is subtraction. 1 minus 5 of 1.660. Go to the table, do the subtraction. This comes out to be 0.0485, correct to 3 significant figures. So now this is done. Question, it's not done. In the same document, formatting errors. That was typing error. Now this time it's a formatting error. And it's a constant rate of 0.3 error per page. Find the probability total number of typing and formatting errors in 20 randomly chosen pages is between 8 and 11. Now the typing error, it followed a Poisson distribution of 0.2. Formatting error follows a Poisson distribution of 0.3. Let X is equals to typing plus formatting. So therefore X follows a Poisson distribution of 0.5. That is linear combination of Poisson variable. You simply add the means. Now 0.5 multiplied by 20 is 10. So therefore X follows a Poisson distribution with 10 between 8 and 11 inclusive. So now this is 8 and this is 9 and this is 10 and this is 11. So you need 4 terms over here. So therefore probability X lying between 8 and 11, let me double check it's inclusive. So this is e raised to power of minus 10, 10 raised to power of 8 over 8 factorial, 10 raised to power of 9 over 9 factorial, 10 raised to power of 10 over 10 factorial, and 10 raised to power of 11 over 11 factorial. You add it all up and then you get this answer. So this is part C. Question number 6. It says a machine is supposed to produce random digits. Bob thinks, so it's a matter of thinking and suspicion and claim. Bob thinks that the machine is not fair and that the probability of it producing the digit 0 is less than 1 over 10. So it's a lower tail test. In order to test a suspicion, he notes the number of times the digit 0 occurs in 30 digits produced by the machine. He carries out the test at the 10% significance level, states suitable null and alternative hypothesis, find the rejection region of the test, state the probability of type 1 error, and it is now given that the machine actually produces 0 once in every 40 digits. On average, find the probability of type 2 error. Explain the meaning of type 2 error in this context. So this is question number 6, a full-fledged question of hypothesis of binomial distribution. First of all, write X follows, let me make this marker a bit thicker, X and make it black. X follows a binomial distribution 30, 1 over 10. And we will be finding the rejection region, that is 10% significance level. And H naught, probability of success is 1 over 10. And H1, probability of success is lesser than 1 over 10. So it's a lower tail test. And you have to carry out the rejection region. So what you do is that you start with 0. Probability X is equals to 0. That is 30C0. Success raised to power of 0. Failure raised to power of 30. You calculate this value. And you write it in percentage, that is 4.24%. Then you calculate probability X is equals to 1. And that is 30C1. 0.9 raised to power of 29, 0.1 raised to power of 1, and then you calculate this percentage. And let me grab my calculator. So that is, but I don't have a calculator right now. So let me just check it from the mark scheme. So therefore, this value comes out to be some big percentage. Now, when I add these two, probability X is less than or equal to 1. That is probability X is equals to 0 plus probability X is equals to 1. That comes out to be 18.4%. That means our significance level is 10%. So this fits inside 10%. This does not. Therefore, your critical region, probability X is equals to 0. That is the true significance level. That is the answer of part C also. That is probability of type 1 error, which is 4.24%. And what is the critical region? Critical region is X is equals to 0. There is only one thing. That means if you get 0 digits, 0 time, that is the only way of saying that that's the critical value. So now, this is the rejection region. Probability of rejection region is the type 1 error. That is probability of X is equals to 0, which is 4.24%. What else? Type 2. So type 2, you flip the inequality. Probability of type 2, given that now the probability of success is 1 over 40, once in every this thing. So now let's write it down. X follows a binomial distribution 30, 1 over 40. So probability of type 2 is probability of X is greater than or equal to 1, which is too much to calculate, which is 1 minus probability X is equals to 0, which is 1 minus 30C0. Success is 1 over 40 raised to power of 0. Failure is 39 over 40 raised to power of 29. And then you use a calculator and then you get this answer, which is a big answer, 53.2%. You can naturally write it in decimals also, 3 significant figures. Now it says, explain the meaning of type 2 error in the context of this question. What is the meaning of type 2? That is, accept H naught when H naught is false. So now when H naught is false, H1 is true. When H1 is true, what was H1? H1 is probability of success is less than 10%. So P is less than 10%. But we are accepting H0. We are accepting that probability is 10%. Now join the two statements. When you join the two statements, what would you read? What would you write? You would first read and then naturally, then you would write in your mind. So the thing is, even though probability is less than 10%, the inspector, is there an inspector over here or is there a person by the name of Bob? The inspector, let me erase it. So since it's less than, even though the fact is it's less than 10%, Bob is wrongly concluding that it's still 10%. So that's an error that Bob is making. Now this looks like the last question. That is CRV. Function is given, quadratic. Show that k is 3 over 16. So integrate the whole function between the limits a and b, and it should equal to 1 because that's what a CRV is. So therefore k outside are 4x minus x square dx between the limits 0 and 2 equal it to 1. I'll do the integration part. 4x square over 2 minus x cube over 3 between the limits 0 and 2, and that is equaling to 1. So I feel like doing the whole thing. That is k. So 2 ones are 2 twos are, so 2 into 2 square minus 2 cube over 3, and this is 0 minus 0 equals to 1. So 2 square is 4 twos are 8, 8 minus 8 over 3. So 8 minus 8 over 3 multiplied by k equals to 1. Am I missing something? Let me double check. So this is 4x minus x square, that's perfect. 4x square over 2 minus x cube over 3, that's perfect. Limits are 0 and 2, that's done. 0 makes everything go 0. So therefore 3 8s are 24. 24 minus 8 is 16. So k into 16 over 3 equals to 1. Therefore k is 3 over 16. So this is done. Find expectation. Expectation of x is multiply x with the function between the full limits, integrate it, first multiply then integrate, that's natural. So therefore this is 0, this is 2, this is x, don't forget the k because people do forget, and that includes me also. This is 3 over 16 and the function is already 4x minus x square. Now when I multiply it, that is 3 over 16, 0 to 2, 4x square minus x cube over minus x cube. So don't do two operations at once. The first is simple multiplication. Now integrate, that's 3 over 16, this is 4x cube over 3 minus x power 4 over 4 between the limits 0 and 2. You plug in the limits and you get the value for expectation of x. So now this thing is also done. Now part B, this looks like a new question. The random variable y has the following properties. Y takes the value between 0 and 5. That's given. It's between 0 and 5. The probability density function is symmetrical. Now we don't know what kind of function is this. It doesn't make a difference. Just draw a graph. I can either draw something quadratic like this. I can either draw something triangular like this. It doesn't make a difference at all. So let me just draw it something like this. Then it says, given that probability y less than a is 0.2. Now the first thing is, since it's symmetrical, so let me just draw it more beautifully, something like this. And then it says it's symmetrical. I don't get a feel of this thing, so let me draw it properly, something like this. Now this is much better. So now this is symmetrical, and first of all, the first thing that I observe is that the value of 2.5 lies in the middle. 50% lies on the right, 50% lies on the left. Probability y less than a is 0.2. That means there should be a value a over here, because it's gonna end at 0, and this is a, and this blue region is 20%. That means that if I label this value or this length as a also, this particular length, so if this length is a, this value is 5 minus a. Do you agree with this? For example, a is 1. So therefore 5 minus 1 is 4. Of course, it makes sense. Therefore, this percentage is also 20%. Agreed? Because of symmetry. It says find the probability y lies between 2.5 and 5 minus 8. So what the examiner is asking is this. You should calculate the probability between these two values, something like this. So now, very simple working. This is 20%, this was 50%, this is 30%, this is 30%. So the answer comes out to be 30% or 0.3. So a very conceptual question based upon your knowledge of O-level maths, based upon your knowledge of common sense. So that completes this paper, November 2021, variant 62 of the S2 paper. Stay tuned for more.